Hello. This is the chapter 2 lesson from lesson 1, and we're going to talk about materials and mechanical design. This is essentially a review of stuff that we've learned in statics and strength of materials. We're going to talk a little bit about the tensile test, and we're going to talk a little bit about some basic properties, physical properties of materials. So the terms we're going to talk about is tensile strength, yield strength, proportional limit, elastic limit, the modulus of elasticity and tension, percent elongation, and the concept of ductility, shear strength, Poisson's ratio, modulus of elasticity and shear, which is actually called the modulus of rigidity, flexural strength, hardness, wear in mechanical devices, machinability, toughness, fatigue strength or endurance, and then creep. These are all mechanical properties of materials. And this comes from the tensile test primarily. As mechanical designers, we are obviously interested in the strength of our material, and that is the amount of stress that the material can take before it fails. If we were to look at a typical tensile test, this would be a typical tensile test of a ductile material. What we're seeing here is we have the force that it takes to stretch the bar, and then we divide that by the original area of the bar. That gives us our stress. And then we have our strain, which is essentially our deflection. How long does the bar's going to grow as you apply load to it? How much does it grow in terms of length? And that change in length, or the change in shape of the part, that's what we call deformation or strain, E. If we look at this curve, we generally have a linear portion of this curve that is called the elastic range. The elastic range, in the elastic range, if you were to let the load go, it would go right back. The part would go right back to its original size. And then you see this is a straight line. The slope of that straight line is the modulus of elasticity, which is essentially the stiffness of the material. The material is going to give when you apply a load to it. That give, if you will, that deformation, as long as it's below the yield strength here, we're going to have elastic deformation. Elastic deformation is not permanent. When you remove the load, it comes right back. Couple points here. Yield point, that's when you're starting to get lots of strain with carrying very little more load. As you can see, this curve kind of flattens out here. That is typical of yielding, where you're getting lots of strain. The very high point of this curve would be our tensile strength, or ultimate strength, S. So that's the difference between tensile strength and yield strength. The elastic limit is beyond that. The deformation becomes permanent. Elastic, I want you to think of elastic as being non-permanent deformation, and then plastic deformation as being permanent. The elastic limit demarks the change from elastic to plastic deformation, and it'll happen right around where the yield point is. Now, proportional limit. Up to the proportional limit, the slope of the stress-strain curve is straight. Okay, so there is a straight line up to the proportional limit. So that straight line has the slope of the modulus of elasticity. We'll look at this one here. A lot of engineering materials don't have a true yield point. And then here's how we determine what the yield strength is. What we do is we have our straight line in the elastic region, and then it starts to curve over. But we don't see it this yield point where you're seeing a lot of deformation without carrying much more load. So in which case, what we do is we will draw a line parallel to our modulus of elasticity line and have it intersect the x-axis at 0.2%. And what we call this is the 0.2% offset. And then we take that line and we project it up, and then where it crosses the stress strain curve, that is our yield strength, S. Okay, so to do a tensile test, what they do is they take a bar such as this, and it's prepared. It's a prepared specimen. It has a prepared diameter, and it has a prepared gauge length. And then they start applying load to it, and then we'll get the final length before it cracks, okay? And then this term, percent elongation, it's really the amount of deformation that the bar went through until it failed. Now that percent elongation is a measure of the ductility of a part, of a material. When I said this tensile test was typical of a ductile part, what you're seeing is lots of deformation before the thing finally actually fails up in here. So a ductile part will go through a lot of deformation before it finally fails. The opposite of ductility would be brittleness, and a brittle part would tend to fail before it starts to deform very much at all. So those are our terms for our mechanical properties. We talked about most of these. Again, it's kind of a review. One of the things I want to talk about was creep, and creep is like it's more of a mechanical property of elastomers and plastics and stuff like that. Whereas if it stays loaded, it can deform over a long period of time. That's creep. Again, not so much metals, but it happens with plastic. And then another term I want you to know, if you don't know already, is called fatigue strength or endurance strength. Fatigue is a phenomena where a part can fail below its yield strength if the loads are repeated and reversed. So if you have a load, even though it's below the yield strength, it can cause a part to fail if that load is applied over and over and over. So anytime I want you to think of endurance and fatigue, think of repeated loading over and over. That's endurance and fatigue. One last slide I want to talk about here, and that is physical properties of the materials. We're mechanical designers, and we like to talk about mechanical properties, the strength of materials, modulus of elasticity, etc., etc. But there are other physical properties of materials are important too. Namely, first one is density. It's a direct function of how much that material will weigh. The next one would be coefficient of thermal expansion. So what happens is as materials are subjected to high and low temperatures, they tend to grow at higher temperatures and they tend to contract at lower temperatures. Now, since a lot of products are used over the entire operating, you think about a bridge, okay, that bridge is out there in all environments. And you think about aircraft are out there in a lot of different environments. And so which case all these materials have to work together, even though they're growing and contracting with temperature at different rates. All the parts need to work together. And then there's thermal conductivity. One of the things of machineries is they generate a lot of heat, so we need to be considerate of thermal conductivity and how we get rid of that heat. And then metals tend to carry electrical current, and so electrical resistivity is another physical property of materials. That concludes this lesson for lesson 1.